Thank you, everyone, for having me. I'm sorry that I missed all, I'm sure, the really interesting conversations that were happening earlier in the day. I had work obligations, but I'm happy to be here now. As Sean said, I'm the energy manager at Cal Poly Humboldt, and I'm here to just kind of give you an overview of what we're doing on campus to decarbonize. So I know this is the net zero retreat, but we're looking at things from more of just a decarbonization standpoint. For a lot of reasons. So I'm going to talk about some of the opportunities, challenges, and our progress that we've made in decarbonizing stuff. And I realize that I'm like the one standing between you and like music and food and stuff, so I'll try to keep it kind of light. And if you have any questions while I'm talking, please feel free to just raise your hand and I'll try and get to that. So let's see if we can get the technology working. All right, so just to set the context of our campus energy, some of you have attended Cal Poly, formerly Humboldt State, but many of you have not. We're a large direct access customer. We have Shell Energy as our contract. All that's negotiated through the whole California State University system, so we don't do that on campus. That's negotiated at the system level. We're a non-core natural gas customer, so we're a large gas user, and we have Department of General Services, again, through the CSU, and then we have a number of small accounts that are our local community choice energy provider. I put here a table of some of our energy use and cost and greenhouse gas emissions for our energy purchases, just electricity and natural gas, just to kind of set the stage. So it's there. I'm not going to read off those numbers, but I've got a different view of all of that information. So that the numbers on that chart I've been put into this pie chart, and I'm not usually a fan of pie charts, but I made this once, and it kind of struck me as the challenges that we sort of all face. So on campus, about 66% of the energy we use is in the form of natural gas, and that's the majority for heating our buildings. We are on a coastal cool climate. We heat basically year-round. We have very little active cooling on campus, so we have a few air-conditioned spaces. Those tend to be computer labs or server rooms kind of thing, but we don't have building-level air conditioning on campus. So the majority of our energy use is for heating our buildings. But if you go look at our costs, basically it flips, right? Electricity is the majority of the actual expenditure that we're doing every year for our energy use. And then if you look at greenhouse gas emissions, it tracks with the usage, where the natural gas is obviously our biggest emitters. So this kind of keeps me up at night. If I think about decarbonizing and moving that big slice of natural gas over to the electricity bucket, thinking about what it's going to do to our energy expenditures gives me nightmares. So those are, I'll just leave it there. So a little bit of background on us and our planning. We made our first climate action plan in 2017, and that was updated in 2022 to include not just climate action, but also resiliency. Resiliency is obviously going to be a big part of adapting to climate change as we move forward. And one of the things that was kind of really big in our CAP 2.0 was sort of codifying that all new buildings would be all electric going forward. There's some slight hedging in there of as long as it's feasible, but our campus administration has really bought into that, and it also is coming from the CSU level, where there's really strong commitment to actually decarbonizing our building spaces. So our goal right now is 2045 for carbon neutrality, and that's in line with the CSU system. It's also kind of in line with the state of California's clean energy goals of being 100% renewable electricity by 2040. So that just kind of sets our background. And then we had a big thing that happened recently, the Cal Poly transition. So if you are not familiar, we were formerly Humboldt State University. In 2021, the CSU system asked Cal Poly to do a self-study about becoming a polytechnic university. And really that's just kind of a tribute to the work that we had already been doing on campus as far as our technical programs. So we did a self-study, and with that became a paycheck of $433 million in one-time funding to help support those programs, which was a big turnaround from what we had been experiencing as a campus before, where there's a lot of budget cuts and declining enrollment. And do you have a question? Oh, no. Oh, sorry. So that was kind of a shock, and in a good way, that we had that money come to us. But the planning work that we had been doing prior to this, and sort of in line with a lot of it, really set the stage that we're getting all this money for infrastructure, and now we've got buy-in from our administration. We're going all electric. So that was a big win for us. So it was kind of exciting. And just to set just a little bit of context, we've got 12 new programs that launched this fall semester, including in energy engineering and lots of other stuff, engineering programs, mechanical engineering. And then we've got 27 total new programs that are set to come online in 2029. So it's a really big expansion of our university, and it's a really exciting opportunity. Okay, So that's just kind of a background, and all electric buildings, and I just wanted to go a little bit over our progress so far. So we had been doing some of this work prior to the Cal Poly transition, and we have a research center on campus, the Schatz Energy Research Center, which I am an alum of. It's on campus, and they do a lot of clean and renewable energy research. They built a new sort of small building that was supplementing their building, and that was sort of the first all-electric building on campus. It's only 2,000 square feet, not even, and it's directly just next toward their existing building, and it's just primarily office spaces, but it is all electric, so it's heat pump, split system, it's just providing air conditioning to the office spaces. It's actually, I don't even think it has any active ventilation. It's just got operable windows. So it was our first foray into heat pumps for space heating. We have obviously some smaller ones for our air conditioning, but so that was a big win on campus. It was a big deal at the time, and it's a great building. It's very beautiful. Another one is the Campus Center for Appropriate Technology, and I'm sure Sean can tell you a lot more about that house on there. It's a live-in demonstration house for sustainability. It had previously just been a residential house, and students have used it to demonstrate appropriate technology, sustainable technology, and in 2021 it was renovated to be all electric. So they have another split system, a residential split system there, and a heat pump water heater, which is kind of cool because it had an existing solar thermal system, and they utilize that to be the preheat for the hot water system. So it's not just a heat pump hot water system, it's a solar preheat hot water system. And that was funded by a student fee, the Humboldt Energy Independence Fund, which actually Michael Winkler had a big hand in doing that. Yeah.
So what's that fund, like the energy fund?
The fund, so that is a student fee fund. So students basically voted to tax themselves at the time for energy independence. It has since expanded as far as the scope of projects on. It's about, I think per student's about $13 a semester collects into a fund, and then students actually propose ideas on what to do with those monies. And so we've done a lot of things. We've done a lot of energy projects as sort of what it was originally founded for, a lot of lighting, but it's also expanded to do more sustainability work more broadly on campus.
So the fund represents the student body in the whole?
Exactly, yeah, and then we've got a committee that votes on what to fund and what not to fund. It's very innovative, it's a popular fund.
Michael Winkler sitting there helped get that passed.
Yeah, Michael Winkler.
When he's a college student.
And then Berkeley also copied it and created their own.
Yeah, it started a kind of a trend of a lot of campuses sort of voting to tax themselves to do these sorts of projects. And then another big win is we have the Trinity Children's Center. This was originally built as a maternity hospital, and then it stopped being that, and it was just administrative space. It's sort of due south on our campus, and then it sat vacant for many, many years. They talked about tearing it down to be a parking lot. And then the state, before the Cal Poly stuff happened, the state actually gave us some funds to turn it into a children's center, to move some of our programs, our child care and also our child development lab, which is associated with our child development program, in there. It's a beautiful space. This picture's not doing it justice. It's just a heat pump sitting on the side. But this one was a major renovation that went from a combination of gas and electric to all electric. And one of the most satisfying days for me as an employee was calling PG&E to tell them to take their gas out of our building. I hope to do that a lot more, but that was kind of a big deal. So it's a heat pump, and then the other cool thing about this building is it has a commercial kitchen because they do actually all the cooking for the child care program there, and so it's got an all-electric commercial kitchen with a full-on electric induction range, and so that's a really neat thing on campus that we hope to continue on our commercial spaces. So we're pretty excited about that, and that was just completed last month. So that was just opened. The children are welcoming in there. There's been some hiccups in any new building as far as getting things to work out properly, but generally the space it's a lovely space to take your children. I'm kind of jealous that my kids are too old to be there, but so that was really great. So this is our progress so far, and it's really awesome. All these projects that I'm talking about were prior to our Cal Poly transition, so we've got some momentum under our belt. So in progress, now moving into the future, the stuff funded by Cal Poly funding, the biggest one currently is the Craftsman Student Housing. And if on the 101, when you're going south, going back to Arcata, if you do that, or when you're coming up here, you will see the construction site. It's near the university. There's a bunch of cranes there, and it's going to be student housing. So it's off-campus housing, but it's very close to campus. There's going to be some bike paths and walking paths that will connect to the campus. It's on the other side of the freeway, which is a bit of a challenge, but I think we will overcome those. 30,000 square feet, 950 beds, so this is a big project. And in addition to like cafe and retail space and other community spaces like a gym and a meeting area. Construction is currently underway and we're expecting to open it in fall of 25. And 200 million of that, $433 million is going towards that.
Is that all electric?
And that's all electric, yeah. So all the stuff that I'm presenting you, these are all electric. So these are stuff that our university has committed to all electric. And I honestly don't know the details of the systems that they're putting in to this particular building. It's under construction, so I assume that it's all been figured out. But yeah, all electric. So that's a big deal. And then our next, I don't have any pictures, so I just grabbed something that looked like technology, is our energy and technology building. And so this is going to house a lot of our our existing engineering programs and our new programs. It's going to be about 70,000 square feet of instructional office space, maker space, machine shops, that kind of interesting lab space, research lab. It's currently still in design, so they're working out. I think it's a schematic design stage right now. So we don't have the final plans, but it has been committed to be all electric. We've just, we put that in our RFPs for our designers and our architects, and everyone's bought into it, and it's pretty exciting because I was a little unsure about this one being a lab space, whether they were going to go for it, but they did. So we're expecting construction to start in the spring of next year with a completion of January 26th, and that's $135 million. It's not cheap to work on our campus. We're a state agency, so we've got a lot of standards that you must comply to in prevailing wage. So it's not cheap, but it's exciting that that's happening. And I don't have a picture for this one, but another one that sort of is near and dear to my heart is going to be our Energy Research and Sustainability Center. It's going to be a smaller building, about 20,000 square feet. It's also still in design, schematic design. It's going to be mostly offices, classrooms, a seminar space, and a microgrid research test lab. So the Humboldt, the Schatz Energy Research Center has done a lot of microgrid design work, and they anticipate continuing to do that in addition to our energy engineering program. We see this as like a valuable training resource for our students. And we're hoping to be innovative in this building. So the details haven't been worked out. We're still in schematic design and there's budget constraints. But we are hoping that this building allows to do some thermal energy storage, not just battery energy storage, but to figure out how that is, in addition to being grid responsive. So some of the research that our engineering department and the Schatz Center wants to do is like, how do you build a grid responsive building? How does that work? What are the controls? It's kind of a space to experiment. So we're pretty excited about that. Again, this is kind of a similar timeline as our energy and technology building, spring of 2024, and opening in the fall. $24 million budget, smaller building, smaller footprint, but kind of exciting. I think this one's going to be one of these sort of heavily marketed building spaces.
Do you know of other universities in our country who have a similar going for it? I do microgrid design. We've got an engineering program that's specific to advanced energy.
There is. Carnegie Mellon has some of the consultants, the architects have done work for Carnegie Mellon doing microgrid research test labs specifically. So there is precedent for it for sure. I think they've got more money than us to spend on their buildings.
What about the other campuses of Cal Poly? Are they doing any energy research?
Oh, really? Oh, nice. Awesome. Sorry, what was that, Michael?
The other campuses of Cal Poly, are they doing very much energy-related work?
That's a good question. Not to my knowledge. I know that Humboldt has kind of been the one that's been, I don't know how many universities have energy engineering specifically. Like mechanical is very common and electrical, and those are obviously integral to this sort of space, but not energy specifically. I'm sure they're doing cool stuff at the other Cal Polys. Not as cool as us, though. I'm biased. And then a campus microgrid. So this is really exciting. I was hoping to be able to say we've got contracts signed, but I don't, and I'm eagerly waiting an email to come in to say we've got contracts signed. But facilities management is working with the Schatz Energy Research Center to design a campus level microgrid, and that's going to incorporate not only the research aspect of it, but the resiliency piece of it. So that was part of our CAP 2.0, the resiliency, and also, not just for campus, but as a community resiliency. It's not a resiliency center, I don't want to say that, but definitely a place where we're serving not just our campus community, but our community writ large. And so we're currently under contract negotiations for a 5.8 megawatt battery, so big battery, 2-hour battery. and about 2.5 megawatts of PV, a PPA. So the Schatz Center is designing the controls and the integration, and they're acting as our owners and engineers, and then we're doing a lease agreement for our battery and a PPA for our solar. And this picture is, if anyone flew in, maybe you saw the solar panels at our airport. We've got I think it's like 3 megawatts or 2.5 megawatts of solar down there and a big battery system, and that one actually participates in the wholesale market with our community choice aggregator, Redwood Coast Energy Authority. So the Schatz Center was integral in that design, and now we've hired them for our campus, so we're excited to do some cool stuff on campus. And yeah, I'm excited about that one, yeah.
For more details, so this campus microgrid, I heard you say, is a 2-hour BESS, which stands for
Battery Energy Storage System.
Battery Energy Storage System. So it means that the whole power of the campus can go for 2 hours.
Well, it depends on the state of the battery, it depends on the loads of the building. It's, it's one of these things of like, it depends. And also the time of year when the outage occurs and how much solar is available. So there's a lot of variables in there. But we anticipate it being, and I am not the one who's doing the modeling. We've actually got some grad students at the Schatz Center who are doing the modeling of like different scenarios, what we can support. But I think, in ideal circumstances, it would be longer than 2 hours. Our current max load is less than 5.8 megawatts, but we anticipate that to grow as we have all these new all-electric buildings that we're putting online. So I'm sorry, that was a bit of a hedge of an answer, but I don't have a good one.
No, it's all right. It's a
how long it could run.
That's good.
So that is in progress. And then farther out, we have another large building that we're going to build, health, dining, and housing. It's going to be about 200 square feet, so that's, again, a very large space. So 400 to 500 bed res hall, a large campus dining facility to go with that residence hall, and then a new student health center. So we have a student health center on campus. We're anticipating building a brand new one and moving it to this new building. And again, all electric. An all electric health center is kind of a cool thing. Yeah.
I'm just curious, like, what's kind of guiding, what you're starting with, is low-hanging fruit right now, some of this further out stuff? Is it purely just like, we have old equipment that we're trying to retire, or is it pure cost, or is it kind of all this stuff together? Do you have like a master plan?
We are actually in the process right now of updating our physical plan, our campus physical plan. A lot of it, like all these new buildings are driven by the Cal Poly expansion. So, the state gave us money, they're like, ramp up, you need to do all these things, here's all this money, make it happen. So that's largely driven by that. The planning efforts are just driven by, our Office of Sustainability and our climate action plan and the need that, or the realization that it's important to do this kind of work. And I think it really made us, we had done all this planning work before we got all this money, so it was just a good synergy. So this one's farther out. This one is not expected to be completed until 2027. We're actually the bid is out, soliciting for our collaborative design build team, so architect and builder for that. Challenges. This is the same chart as you saw earlier. Again, the challenges. We've got all these electric buildings, and that's great. I'm really excited about all these electric buildings, but this is the thing that makes me really nervous, is electricity is really expensive. And I mean, natural gas is also expensive at times. We saw a big spike here in California and probably elsewhere in our natural gas at the beginning of the year. It went up like 4 times because of everything, the situation in the world, and we had a particular cold spell. So this is just like the thing that keeps me up at night, is how am I going to reconcile these two things? And I know you get heat pump, it's not a one-to-one conversion, you get some efficiencies there, but energy is expensive, electricity is expensive. So if anyone has any ideas, I mean, the solar's going to help, yeah.
The solar, like how much can you cover the campus with solar?
So it's a good question. So we are a forested campus, we have lots of trees, we have lots of fog. We are kind of maxing out our solar, and we're also very constrained. So the campus, if you haven't been there, it's right next to a hill, and then there's the freeway on the other side. We don't have a lot of space to grow. The 2.5 megawatts is, we can go a little bit more, and our new buildings will all have solar and be solar ready for sure. But as it stands now, the solar that we're planning is about, I want to say about 30% of our current load to cover it. So, getting to net zero, I think, is going to be super hard. But that, again, that's not really our goal necessarily as a campus. It's mostly decarbonizing. Yeah.
Is your campus similar to other campuses in which you would have like underground heating loop and things like that?
That's a great question.
I'm wondering if the energy loss from the natural gas is equivalent, because I feel like it's overstated because you have so much leakages.
Yeah. So we don't have a central plant, and we don't have district heating. on our campus. Our buildings are basically all boiler systems on the campus, and we use hydronic heating primarily. So most of the heating is just boilers heating water, and we don't have a campus loop. At one point we had a cogeneration plant, but it never really worked out. So there is a loop for maybe a third of our buildings, but it's never been used for heating. So it's all on the building level. Yeah.
You mentioned the cogen. Are they thinking about biogas or CHP?
No, so we had a cogeneration. It was a 350 kilowatt cogeneration over on our housing, and they did use that heat for heating the housing. It failed catastrophically a couple years back. It was built in the late 80s, and then we put in a cogen in 2004, 2005, and it just never really worked. It was a diesel engine, natural gas, and it just problems from day one. They could never get it to work, and so I think they've been largely turned off to cogen. Some other campuses in our systems have fuel cells that they are also doing cogeneration with, but we also have heard many problematic things for those campuses as well. So, and we don't really have, our campus is kind of small, and we don't really have space for like a large central plant. The cogen that I talked about from 2004 is actually the location is being replaced with a large generator. That's part of our microgrid. It's battery and solar is very sexy, but also when that runs out in the middle of the winter, when there's not much sun, you're going to have a big diesel generator backup. So we don't like to talk about it, but it's there.
What about geothermal?
Geothermal is a really good question. I'm kind of excited to explore that. We have not done much on that, but I think it's definitely an opportunity.
Well, I have one for my house. I have some experience with that.
Yeah, Michael's got probably the only geothermal in the county. I'm going to go here and then over there. Yeah.
How much conservation or load reduction is in your plan?
That's a good question. A fair bit. I mean, we've done a lot of just obviously the lighting. Most of our lighting is now LED. We have still a lot of opportunities. Our buildings are old. I would say, the median age of the buildings on campus it's like 46 years. I think I calculated that out a while ago. So we do have a lot of opportunities to do that. And we've been putting building controls. We upgraded a lot of pneumatic controls to DDC. And so there's opportunities just to do sort of, building level tweaking and commissioning. And that's definitely part of the plan. I don't know how far that gets us, but it's definitely something that we're thinking about.
And just to follow up, EUIs, are you guys tracking those and kind of how I'm just trying to get a feel for, are your buildings like turkeys or are they way?
It depends. I think we have a mix. Some of our biggest turkeys we've addressed. I've actually got some students who are going to look at doing some updated EUIs for our building so that we can see really where that lies. And again, that's going to help that we've done a lot of metering. So we didn't have good metering on campus. That's another thing we've been working on in the last several years is getting gas and water and electric meters at the building level that are, hooked to JCI so we can actually get all the information out of it and do that work. So it's definitely in there. As I said, our physical plan is, being updated. So we're definitely thinking about all this stuff. Yeah, good question. And then I think over there, yeah.
I was curious, maybe I missed it, for the introduction of these new electric buildings, do you know the rough timeline of when these are going to be put in place, and how does that sort of compare to the timeline of the new offshore wind that's in development as well? I imagine that there's a different price of electricity given, or post completion of that project.
I haven't really been thinking about it in that terms. It's a good question. We are direct access, so we are not, the energy and that could change. We could purchase offshore wind. I don't anticipate the offshore wind honestly being cheaper than what we're paying right now, but time will tell. I don't have a good answer to that question. It's an interesting one. Yeah, back there.
Sort of a weird question. Thinking about science buildings, particularly the Chem building, you need gas for Bunsen burners. Is that going to stay in place?
I know I had that same question. No, there are electric alternatives to Bunsen burners. We're not going to run gas to a building just for Bunsen burners. If we have to, we can bring bottles in.
And it just requires like new equipment and ways of doing things.
Yep.
It's like induction plates, but you're not
Yep.
using
Exactly.
glass or using something. Okay.
Yeah. And so I was, that I had that. I was like, are we going to be running gas to these buildings so we can run the Bunsen burners? And I don't want to, but yeah, and people.
It seems like something you should maybe, like for safety reasons, just like I can't believe we're still doing this.
Right.
I don't know. It almost caused so many fires at that.
Yeah, and that's a good point, actually. One of the things that I didn't mention is here is part of the money, the Cal Poly money, is also going to renovating some of our older science buildings in particular. So Science A, which is our chemistry building on campus, is going to get a major facelift. And I'm hoping that we're going to be able to make that one all electric. We're not that far yet, but that would be great. Get the Bunsen burners out. Science, which one?
Science D. Right?
Science D. Oh yes, that one I want to tear down. But
Yeah, a lot of people want to tear down.
yes. Let's see. We'll go here and then back there.
I had a question on the challenges. Have you tried doing these pie charts for the older buildings that haven't been touched and the new ones?
That's a good.
Because I think looking at it this way, yeah, of course, because you have a bunch of old buildings.
Yeah.
But you want to look at what it looks like now.
Yeah. Well, I mean, this is now for
No, but
for
it's
context.
now everything. What
Yeah.
I'm saying is
Yeah, oh,
do
yeah.
the ones that haven't been fixed up and the ones
Right.
that have.
Right.
And go, boom, look, the costs have just shifted.
Yeah.
I just think you have a really good case study.
Yeah.
Yeah.
We're.
Thank you for your work.
Yep.
When you said ground source heat pump, did you mean, when you said geothermal, did you mean ground source heat pump, or did you mean like ground hot heat pump?
Ground source heat pump, I think, is right there. Yeah.
I'm looking out there at this reserves. Are you guys doing any? Do you know if there's any company doing tidal energy right here?
I know that the Schatz Center has done some research on tidal energy. I don't know exactly where that landed. I don't think that, obviously they're not putting anything out there right now, so.
We've got a huge offshore wind field that we're
Yeah,
developing.
the offshore wind
That's
field
real.
is definitely being developed, for sure. Any questions? We got more stuff over here.
On your direct access contract, that seems you have to meet the California. Is the Chancellor's office trying to push to increase those standards?
They very much are. Yeah, the Chancellor's office is trying to get that more renewable energy, but it's expensive. I mean, also trying to balance the cost aspect of it. So it's they don't have an easy job negotiating those contracts, and electricity prices have skyrocketed in the last 2 or 3 years. But yeah, they definitely are trying to use their size. About half of the campuses, the CSU campuses, are direct access, so they do have some negotiating power. Did I see another hand over there? Is that? I got just a couple more slides. Oh yeah.
If you're increasing your electrical capacity on the campus, is your substation size, will you have to increase the size of that, or?
I think I don't think we will need to. We're in discussions with PG&E, our electricity provider here, just to make sure that we're not in, there's gonna be a big interconnection study that's gonna have to happen with our microgrid and our battery and our solar. We did a pre-application study, just sort of a quick back of the envelope that they'll do just to look at things, and it looks like we will have the capacity, but we're still, we haven't done the detailed analysis yet, but it's definitely something that's on the radar of folks. And I was actually just talking to our PG&E rep just to make sure. And it's kind of an iterative thing. As we know more about the buildings and what their loads will be, we're sharing that with them to make sure that they're thinking about that going forward. So I think I've got 1 or 2 more slides. So some of our other challenges: we have a large stock of aging buildings, existing buildings, and the cost both to renovate and to operate. Like I said, that pie chart keeps me up at night sometimes. And then refrigerants. The low global warming potential products are not really commercially available, or at least our contractors are not finding them. And that's another thing that I think about. So the Schatz Center, the first building that I showed, the small all-electric one that's got a heat pump in it, I think it's got R410A in it, and it actually had a leak in the refrigerant lines, because the refrigerant lines are running, and my husband, who's actually a professor there, did the sort of back of the envelope calculation of what the global warming potential of that leak was based on how much they put back in, and it turns out like it was worse than if they had just been running on natural gas the whole time. I mean, the building had only been operational for like 3 years at that point, but like that kind of stuff, the unintended consequences of doing all this these changes, I just want to make sure that we're not doing that. And then also there's this, I worry about that we're maybe kind of an awkward phase of the transition. I think like in 5 or 10 years, there's going to be all these really great products. But as we're doing this now, I worry that we're going to be like the pin-based fluorescence era of like whatever the heat pump is. We have some buildings that our newer buildings were built in 2006 2007 and 2010, and they're just filled with like T5s, which are hard to find LED replacements for. They're more expensive, and the pin-based fluorescents, which are just a pain in the butt, and everybody hates them. So there's like, I worry that maybe we're getting in like the middle school awkward phase of all this heat pump, which isn't to say we shouldn't do it, but I just this is one of these things where it's like, gosh, I don't know, we're going to do this, we're going to be on the bleeding edge, and then 5 years later you're going to look like you've got the original iPhone and everyone's got a 15. So that's a challenge. I don't know what to do about that one, but yeah.
Regarding the low greenhouse potential for like water heating or combination systems, are you guys looking into like sand ends or CO2 based?
Yeah, I mean definitely, but I don't know on a building scale. That would be. And I've heard of like sort of building level ones. Definitely for water heating, I think it's possible. The Nile, I think, is another one that does CO2 based ones. But for large space heating, I just don't think we're there yet, particularly for the cost of it. But I'm definitely interested. If we could have CO2 based systems, I think that would be great. So that way, when you have a leak, it's like not any worse than just whatever you would have burned, the CO2. So yeah.
They work better in a climate like this too, anyways.
Yeah, I mean, I think it would be really cool to have a stand-in on campus, just to have, to have one there to look at and to research. We sort of looked at it for CCAT, but it was just, they were so expensive. But again, like those prices are coming down, so maybe the buildings that were in design right now have one thing, but the ones that are a little bit later down the line are something different. And I'm still waiting for the people to come in and have a drop-in replacement for a 1 million BTU boiler, so that we can that will fit in the footprint of a natural gas one. And when that unicorn arrives, I will sing and do a happy dance.
CO2 is pretty mature for water heating, but not for space heating.
Yeah, and most of our I mean, we are heating water to heat space, but yeah, it's not. They don't have the capacity.
Yeah, for domestic hot water, it's mature for space heating.
Yeah, I mean, and we could do that, but the domestic hot water is a very small slice of our. Yeah.
This morning, my first presentation, I showed folks here Flowtech and also Link by Watts, which are two large CO2 heat pump water heaters. But Flowtech is actually hydronic. So it's for space heating. It's just what you're looking for, and it is 1 million BTUs.
Get there.
Yeah, I mean, I would be
so
interested.
we might have the technology just now.
So this is this is why I was excited to come here, because you guys can help me with all of my problems. And that's all I've got. I think. I'll take any other questions. Thank you so much. Any other questions? More questions or not? Yeah.
That fund, if like kid wants to set that up, or some student wants to set that up at their school, is there any models that actually allow the fund themselves, like to kind of like take on like investor type options where they can generate kind of maybe to a green bank and generate revenue, even though the project is just for the campus, but like it can actually like, that makes sense, like fund itself or something?
Yeah.
Financial instrument.
That's interesting. I mean, so when we started the fund, I mean, I wasn't there when we started it, but operating the fund, there had been some talk, particularly if it's just energy focused, where the campus could potentially capture the savings. So it's like if you have good monitoring and whatever you do your lighting project and it saves you X number of dollars a year, that could go back into the fund so that it can grow and expand. We had challenges with that mostly because we didn't have the good metering in place to do it. I don't know if that's what you're thinking. So that sort of thing is possible. You just have to think about how you implement it. And as the fund has matured over the years, a lot of our projects aren't energy related. They're more sustainability focused. We've done a lot of waste projects, and those are harder to capture a savings per se. So yeah.
Recycling.
Yeah, we've done a lot of recycling projects and composting projects, and some other sort of community-based projects, allowing students to do sustainability events and things of those sort of nature. So.
And water dispensers are under energy intense funding?
Water dispensers, yeah. We actually have water filling stations that were funded by HERF funding, so the COVID funding. So now they're widespread all throughout campus. Yeah,
so I encourage you guys, because it's 5:05, and there's another massage therapist that's waiting for you. And the food's about to come, and the steel drum music, I heard them starting to do little ding-ling-ding-ling-dings. Go up and ask Andrea your questions, but let us enjoy the dimming of the day and the sunshine. Yay!